Hey guys, welcome back. In today's lecture, I'm going to talk about the product and quotient rule of a complex number. Okay. Now, just a quick reminder from the previous lectures that cis theta is equals to cos theta plus I sine theta. Okay. So cos also cis theta is just basically a shorthand of saying cis theta plus I sine theta. Okay. Now, what if I have a complex number R1 cis theta 1, and then I have another complex number that is z is equals to r2 cis theta 2. Okay, and now what is the product of w multiplied by z? That would be r1 r2 cis theta 1 and then cis theta 2. Yeah, so if we expand the bracket, that would be r1 r2 cos theta 1 plus I sine theta 2 multiplied by cos theta 2 plus I sine theta 2. Right, so let us expand this bracket, okay? So that would be, so you would expand it just like any other quadratic or any other factors that are multiplied together. So that would be r1, r2, cos theta 1 cos theta 2 and then plus I sine theta 2 cos theta 1 and then plus I sine theta 1 cos theta 2 and then finally plus I square sine theta 1 sine theta 2. Okay, running out of space, but that's okay. So let us collect the real part and the imaginary part. Okay, now the real part would be uh, cos theta 1 cos theta 2 and then minus sine theta 1 sine theta 2. Yeah, and then plus I into, so this is the imaginary part, sine theta 2 cos theta 1 and then plus sine theta 1 cos theta 2. Oop. Cos theta 2, there should be 1 here. Okay, so now from our trig identity, yeah, from our trig identity that cos A plus B is equals to cos A cos B minus sine A sine B. Yeah? And then from sine A plus B, that is equals to sine A cos B and then plus cos A sine B. Okay? So that means that this part should be cos A plus B or theta 1 plus theta 2, and that one should be sine A plus B as well. Okay, so we've arrived to a conclusion that that R1 times R2 is into cos theta 1 plus theta 2 and then plus I sine theta 1 plus theta 2. So in other words, the product of W multiplied by Z is equals to R1 R2 cis theta 1 plus theta 2. Okay, it's that simple. So just to recap, the radius of the or the modulus of the complex number, they're always multiplied by each other. Okay, can you guys see? So it's R1 multiplied by R2, but the angles they are added together, as indicated in the plus sign here. So let us do an example, a real example. Let's say we have Z is equals to 18 cis of 2.56 radians, okay? And that's W is equals to 6 cis negative 1.44, right? So ZW is equals to 18 multiplied by 6 cis and then plus the angles together. So that's 2.56 plus negative 1.44. So that'll be 108 cis 1.12. Okay, so if we need to express this in the rectangular form, that will be 108 into cos of 1.12 plus I sine of 1.12. So that would become 42 or 47.05 plus 97.21 I. Okay, so this is the proof for the product rule, and also for the quotient rule. If you have W divided by Z, okay, now let's say that W is equals to R1 cis theta, theta 1, and then Z is equals to R2 cis theta 2, then W divided by Z, that will be R1 over R2 cis, but this time it's the difference between the angles. So it's the top angle, so that's the angle from the top, and that's the angle from the bottom. Okay, guys, so I hope you guys understand. And so just remember, you don't have to remember the whole proof of it, just to know what is the result. So this is the result. Okay, so when you multiply two complex numbers together, the radius is always multiplied together while the angles are added together. Okay, while in the division, the radiuses are divided against each other, and we take the difference in angles. Okay, guys, I hope you guys understand, and I'll see you guys in the next lecture.